presenting our publisher-subscriber code-based architecture that we used for the 2023 Power Play season.
Have you next? Sure. We're gonna have to put
We have spent 8 years in FIRST. This is going to be our 7th year in FTC, and as Technibots mentioned, we're based in Palo Alto, California. We're a team-based, we're a student-led team. So we research our own projects, raise our own money without much help from our coaches. We pride ourselves on that, and we've actually accomplished a lot of things that we're very proud of. Our team philosophy is go big or go home. And that's an umbrella term that we basically use to define a lot of what we do as a team. But mostly we strive for simple, efficient, and high-performing designs, whether that's in hardware or software. Today I'm going to talk about one of our most advanced software projects, which is the PubSub code-based architecture. Last year, we used PubSub for a variety of reasons, mostly because it decouples code, and in doing so, it simplifies information sharing between mechanisms and makes it so that processes don't shut down when others do. And that can often be the difference between winning or losing a match. Because if you can still drive, you can play defense. Whereas if your entire code base shuts down, you can't really do anything. We experienced that a few times at Worlds, which we're not very proud of, but the resiliency of our publisher subscriber architecture helped us a lot with that. So we were inspired by industry level software after talking to Nero, which is an autonomous vehicle company based here in Palo Alto. You can see their vehicle on the slide. So the code on this slide is almost universally used in FTC, and there's nothing wrong with it because it works. And I'm going to assume that most FTC teams here can relate to this code. Basically, you have a while loop, and inside of that while loop, you run all of your logic. Problem with it is that it's not very easy to modify or test specific parts. For example, if I wanted to take just the intake system with this code, I would have to comment out all of the non-intake code and then try running it. Except, for example, if I tried running it, then it might break when it tries to call outtake due to a direct dependency on outtake. And it breaks because we commented out the outtake class and the entire robot crashes, and we can't test just the intake system without modifying the intake code. And that doesn't really change much. You can always just change the intake code, but that does make it a bit harder to debug. And in FTC, without publisher, or anywhere really, without publisher subscriber architecture, direct dependencies are very common, so it's hard to test specific things. And while this example is anecdotal and has a lot of what ifs, the situation is very common in tightly coupled systems with a lot of moving parts, such as a robot. This is where PubSub comes in. Publisher is an orchestrated message bus where publishers publish messages to topics, which are received by subscribers. So you can think of every mechanism or process as a node that runs on a separate thread. There's no communication between nodes without orchestrator. Orchestrator has to facilitate all communication between nodes. So in this diagram, you can see a gamepad node, which publishes the gamepad state around 20 times a second. Let's focus on the gamepad/1/x topic. Here, it publishes a Boolean value with true if the X button is pressed and false otherwise. Intake node uses this subscribed to annotation to mark a method as callable when a new message is published. So when a new message is published to the gamepad/1/x topic, orchestrator will automatically call this function called start intake. We run some logic, and at the end you can see that we orchestrator publish. This uses orchestrator to publish a message to the topic outtake/begin, which is listened to by the outtake node. And Sorry. So this is a very simple logic flow that we can use with Orchestrator, but in a real robot with a lot more nodes and moving parts, these diagrams can get very complicated. So we don't draw diagrams for them. Node is that no node knows about existence of any other node. It just assumes that there's a node there. So here you can see that Orchestrator and Publisher Subscriber is pretty easy to use. We have a sample intake node, very simple. You see in the constructor, we declare some variables, and we have a subscribe to value, sorry, a subscribe to method that is called when a new message is published to that topic. In real life, this node would be much more developed with a lot more code in it, but for the sake of example, it's kept simple. So Orchestrator parses these annotations, which is a Java feature, in order to make this development much easier. Orchestrator and the pub sub system is very developer friendly. So if we go back to our previous example, when we want to test just intake, our solution is we just don't start any other nodes. We only start the intake node. Intake node does whatever it does, and it publishes messages. It doesn't call the outtake functions directly. And what this means is that nothing breaks, because intake doesn't know whether that is received or not, but it doesn't need to. This highlights something very important. Just because a message is published doesn't mean that nodes have to receive it, and just because a node receives it doesn't mean that only one node or function can receive it. So this is example teleop code. Again, very simple, but this is how we might go about testing just the intake node. Comment out 2 lines, and without needing to modify any internal node code, we can test the intake code itself. You also might notice that the while loop, while op mode is active, is empty. And that's because Orchestrator can use other annotations to call update functions within nodes. So we don't actually need to put anything inside of that while loop. As you can see here, there's no direct dependencies between nodes. They don't know whether other nodes exist or not. They only know that Orchestrator exists and that they themselves exist. Orchestrator also has the benefit of being very helpful when handling live data. So last year we had an odometry that used data from encoders and IMU, but all of these measurements came in at different times and at different rates. So what we did is we subscribed to the data and could access the latest message without waiting. Odometry node then receives messages from IMU sensors and can update with a fixed frequency instead of wait for messages to arrive. To very accurate and very efficient odometry, which is accurate to about half an inch throughout a 2.5 minute match. Here we have the pros and cons of pub sub listed. Main pros that just to robotics. It can be used in any large software project that has a lot of interconnected and moving parts. Also, it's a very good learning experience to make yourself. We recently learned a lot about how to do asynchronous programming correctly. It's also very helpful for development and testing. That's something that we definitely benefited from a lot as a team last year. But the cons is that for simple and small software projects, there's only usage cases for it when there are out of moving parts, such as a robot. If it's incorrectly implemented, it may be difficult to debug, but we can leave that up to you. Starting publish subscriber architecture. 20 power play season code is available at this list. And if you want to learn more about it, you can just Google it. There are a lot of good resources online. We recommend writing your own system instead of copying other code. such as ours, because that really helps you understand how it works and what you can do with it. I'll now take questions. I believe there's possibly some in chat. Okay. There are not. I don't have a question. I believe that there are no questions.
I have a question.
Oh, we have a question.
What's the performance cost of any of doing it this way? How efficient is it?
I don't think you heard.
Okay, so the question was, what's the performance cost of the system, and how efficient is it?
It's actually surprisingly efficient. It's very simple Java code, and it's also multi-threaded. Since every node runs on a separate thread, you can utilize the processing power of the control hub and other devices that you may run your Java code on. So it's much more performant than you would think. We haven't noticed any significant, or we can run update functions that update hardware about 20 times a second.